Hey guys, what's up? Eddie Alho here with KissAnalog.com. Guys, we have Toolour. I don't know how to pronounce it. It's spelled Toolour. Toolour. They make like those helping hand, a lot of different things for soldering, but they also have this 2-in-1 soldering station. It has a hot air and an iron. And then it says it comes 10-in-1 tools. From the picture, looks like it comes with side cutters, a bunch of other things. So, and there's probably attachments for the blower and the hot air gun. So let's check it out. I mean, this thing is really inexpensive. I think it lists for under like $68 around there, some US dollars. But I believe I've seen it on sale like pretty much all the time for like around 65 right now until somewhere in October for next month. I believe it's like 55 bucks. That is absolutely insane for all the stuff you get. So is it any good? Let's check it out. Let's come over to the bench. All right, I just want to show you the box because there's a lot of information. Here's the back side. This is one side. That's the temperature range, 200, 450 C. And it says precise temperature control. Okay, it says ESD safe. We'll test that. Fragile. Huh. All right. And then here's the 10-in-1 tools. Here's all the stuff. That's kind of a graphic picture of it, I guess. Opening up the box. Okay. There's kind of a specification sheet. Heating time, less than 20 seconds for the hot air. Same for the soldering iron. So 60-watt soldering iron to 600 watts hot air gun. That's pretty wild. Okay, airflow 20 to 120 liters per minute for the hot air. And 470 grams total weight. So, okay, here's some troubleshooting guides. So it looks like it has a nice display up here, right? So COR, that's if the cord's not plugged in, the power cord. SC is a temperature sensor, insufficient airflow. HE, heating cord failure. Okay. Well, that's nice that it has all that. And package contains 2 tweezers, a cutter, desoldering pump, IC puller, air nozzle, soldering tips, user manual, cleaning sponge, power cord, soldering station, soldering iron handle, hot air gun. Let's open it up. Okay, now, by the way, this is that dense poly foam, so very protective. Wow, holy cow, look at all this stuff. Okay, there's some side cutters. Looks like the edges match without, being offset, so that's nice. Good clean cut. By the way, those are nice rubber handles. Okay, looks like some assembly work. That's for the hot air, I'm sure. Okay. We have a hot air. Okay. Heat sensor. I don't see any triggers or anything, so I think hopefully it's one of those things that turns itself off when you put it in the holder. But yeah, I don't know. We'll see. I mean, that is a metal bracket down here in the bottom, so it could have like a magnetic sense. It says Hall sensor, voltage 110. Okay. There's a plug. It looks like 5 pins in there. Okay. All right. Here's one of those nice vacuum pumps. Man, I used to use these things a lot. Yeah, it has a nice pull. So, and I'm assuming this black plastic, I don't know if it's ESD. That's kind of what it looks like, but what else we got in here? Power cord. Oh, wow. Okay. Here, let's move this box over. Oh, some solder. It's 6337, which is what I prefer instead of 6040. It has an optimal melting point, so it stays in the molten state for the least amount of time. I mean, okay, so here's tips. Looks like there's 5 tips. We'll pull those out, take a look at them. Oh, and there's one on the iron. Okay. You know, I actually did a short video on this, so there's a bit of heat on that. I must have tried that out already. God, it's been a while. I kind of forgot. Those are very sharp. Holy cow. ESD 11, ESD 15. Okay. Okay, that's an angled one. And again, very sharp. Holy cow. So you can pick up some small parts. And just kind of an inexpensive Phillips, probably to assemble these nozzles. All right. The other thing we have in here is the stand with the sponge. It's always fun to put water on those the first time, right? And then there's this. And this thing is super lightweight. So it's got to be a switching power supply because that does not feel like it has a transformer in it. That is just lightweight, guys. So yeah, there's the spelling of the brand. Looks like we have power buttons on either side, up and down, plus minus, and they're both 3 small pins, 2 large pins. Okay, on the bottom, there's the back side. So we have a fuse compartment here on off. So we have a hard power on off switch back here. Okay, and there's a little platform for 3 nozzles, air nozzles, like I'm assuming that's what it looks like. Oh, what else do we have in here? Some plastic jobber. Don't know what that is. Okay, I think that's it. That's bottom of the box. All right, the soldering iron, nothing fancy, nice kind of soft rubbery thing, the orange part, the rest of it's hard plastic, 60 watts for 110 volts. There's a tip. So this is the type that has the, well, you can see the tips there. The tips go over the top of the ceramic heating element. Let's pop off that so we can look at it. Yep, there's your ceramic heating element. All right, so then this thing just, the tip just kind of goes, it's fairly snug, okay? And then that little collar will hold the tip down and screw on. All right, and so I just put the screw in with the nut on all 3 of these guys, and there's a small, a little bit larger, and a little bit larger even, the 3 bears. All right, so I have to loosen those screws, and that'll mount right there. All right, so that's the type of thread. It almost looks like the thread you'd use for a metal insert, but there's no metal inserts, just plastic. So, and it was pretty stiff coming out. So let's put the bracket. Okay, guys, that's how it fits on there. Just a slight angle down and just kind of drops in there. So, all right. All right, so you just push it in, and then this little metal collar goes up and tightens it in. It's interesting, one's black and one's silver, right? You got to find where the key is, and then it slides in. And all right, took 2 hands for me to hold this so I could push it in nice and snug before I could do the collar. So there we go. It's getting time for a power cord now. Okay, guys, to check the ESD, what I want to do is put this on the 3rd prong, the ground prong, okay, my meter here. And then I'll take this guy and connect it to the metal tip. And we get about 1 meg, which that's about right. So if you had an ESD, it would be dissipated to ground, okay? It wouldn't be shorted. You wouldn't want to have, you know, create a short there, right? So you got 1 meg ohm resistor. There we go. I had to pull it out so I could just grab the tip. So there you go, another 1 meg. Now I'm curious. This and this are probably grounded together and then grounded with 1 meg ohm resistor to the chassis ground or earth ground. Okay, it looks like they got about 20 ohm. Well, maybe it depends. You know what? Is this loose? Hold on a sec. Let me make sure the tip's on there tight. Okay, I had to put this tip back on tight. So about 1.5 ohms between those two. All right, let me turn on the power. And nothing. So, okay, you got to turn on this. Now, it's nice, solid. I know on the camera it's kind of jumping all around the place, but SLPC Okay, and then here, let's turn on this side. Yeah, sorry about the camera. It's doesn't like this display. It must be the refresh rate or something, but it's nice and solid. It says 69C on this side, SLP. If I take it out, oh, look at that. So it does. Oh, and then the fan starts going. If I put it back in. Okay, the fan's still going because it tries to cool it down. And yeah, SLP, pretty cool. So lift it up, and the temperature's rising, 187, 200 something C. The soldering iron's up to 338 already. Okay, it looks like it's reached 350. They're both 350 now. That's pretty hot out here. I'm reaching way out here, so that is pretty cool. And all right, so we saw this side of this sheet, right? But we flip it over, and there's all the instructions. So SLP is for sleep, and yeah, it talks about all the different setups. So it talks about how to calibrate there in the lower right corner. Yeah, so everything looks like it's here. Now, so the up-down arrows are for the airflow. Okay, and then we got the temperature on these two buttons. So, okay, let's see how it works. All right, guys, again, just show you the tools and the tips. So we have these conical ones, you know, cone shaped type. So really fine, you know, pointy one there. This one's not as pointy. And the one I think I put on there is in between these two. And then you got that little kind of wedge one. And that one's kind of almost like a screwdriver, another wedge type. So you can see the one on the right has more of a kind of a sharp edge on both sides, where this one on the left is kind of flat. And then of course you get this wedge type for doing, you know, large things. But guys, I'm gonna have to go look at some pictures because I still don't know what this thing is. It looks like it screws onto something, but I can't see where it screws onto. And then maybe it's a place where to put solder on. So maybe that's what it's for. All right, guys, this is a board I want to unsolder a FET because I have a bad one. You know how you can test a bad FET real quick? I put my meter in diode mode, okay? And then between drain and source, there's a body diode. See, 0.47. And if I go here, 0.46. Can you see that? Okay. Then if I go this one, 0.46. So I come over here, 0.47. 0. Drainage source shorted. Doesn't matter what direction I go, it's short. So drainage source typically shorts on a FET. So quick way to check, see if it FET's good. All right, guys, I put the smaller nozzle on this, and it's a 350C. And it says it's up there already. It was pretty fast. So I'm going to see if I can unsolder this guy nice and easy. Okay, I cranked it up to 99, the highest airflow we got. I got the temperature at 361. All right, so just to test, I can heat solder, melt solder right here. See that? So I think it's just because the board is a thick, heavy board, lots of copper on it. Big, heavy power traces, big, heavy copper planes. All right, that seems to be pretty difficult on this board. All right, guys, so I just put this wedge shaped tip on, and we're going to try that. So we will try this. Okay, so the thing is, I like to put a little solder it came up to temperature really fast. I like to wick it. It just gets a wet. Having a wet tip helps. All right, guys, let's try the tools they gave us and see if I can do this around the camera. Get it soldered or hot, and then you get it in there and try to get the nozzle over the top of it. Trying to hit the pad and the lead at the same time. Okay, that's pretty close. Let me know if you guys have better luck at hot air guns. I haven't really used hot air guns much, very little. But I understand that's the way to get some certain chips with lots of pins on them out. So, but they're usually, those kind of chips are usually on, digital stuff with boards that aren't so heavy with copper traces and copper layers. Okay, guys, so when you have something like this, a big part, sometimes it's difficult to get all three legs unsoldered and separated. So if you just clip off the part, then a lot of times, maybe I'll leave the middle one on. And then, well, no, I'm going to cut it because it'll soak up heat. So, all right, those are the clippers they gave. They work fine. They work great, actually. All right, then if I can bend these up, and maybe I'll clip off that end piece right there. Wow, that took off like a banshee. Okay, so these Knipics, a friend of the channel sent these to me one time. Our Canadian friend, Joey. Thank you, Joey. Okay, I'm going to straighten those up like that. And the reason why is when I heat it, then I can drop this right over the center and suck it up all the way around the pad. So let's try that. I got to turn on the soldering iron, had it off, took a break, had a job thing I had to do actually. Okay, there it goes. I would bet that took 20 seconds, maybe a little bit longer to do that. I feel a good suction there. I can see the solder start to flow. I wait to get nice hot and then hurry and do that before it cools. Man, that board is thick and it has a lot of copper, so that makes removing these things very difficult. What temperature do you guys do this at? I'm going to turn it up to 360. Get a little more heat. Yep, see that one come loose? Okay, that one I think is ready. Yeah, there we go. All right, guys, so then to replace this, you place this right. I'm going to clean up those pads before I do this, but I'm going to size this, with the screw. Okay, so let's just say I put a screw in there just to kind of place it right. And then, so basically, I'm going to hold the lead right here and bend it. Okay. Shoot, my camera turned off. I just kind of cleaned it up. Usually I use cotton swabs and some alcohol, but I'm out of cotton swabs and I'm running out of all my supplies, so I need to get new stuff. How do you guys clean it? Yeah, usually I have, and sometimes even like an old toothbrush or something, but yeah, that looks pretty good. Alcohol does a pretty good job. Hey, just in case you're wondering, I was using this to keep my tip clean. Normally I'm happy to do a sponge, but I wanted to keep this new because I'm not sure what I'm going to do at the station. So I wanted to keep it as new as I could. Okay, so I'm going to go ahead and solder this. Now I'm going to heat up the pad and, well, I'm going to get the tip wet a little bit. Okay. Then I'm going to heat up the pad and the leg together. And I'm not going to put a ton of solder like the other person did. You put enough to sink inside the hole, but you don't, if you keep on feeding it, it's just going to drip through and you're going to create a pond of solder on the other side of the board. So I'm watching for the solder to kind of go around the leg. Okay. I kind of move the solder around the back part of the lead so it gets everywhere. Now, I need more practice. It's been a while since I've done a lot of soldering, but I think that's going to be good enough. All right, guys, this looks different than anything I've seen before. This is interesting. The power comes in here, right? And goes through the fuses and everything, comes out here, okay? I'll show you where that goes. The green wire comes to this blue wire, and because it's all plastic box, it doesn't have to go to the metal chassis, but they're just using it for the probes, 1 megohm to the probes. So underneath that capacitor right there, there's a surface mount, small resistor, and that's the 1 megohm resistor. And then that's a Y capacitor, which I don't know where it's going actually. It's probably going to a line or something. So, okay, so guys, it's just kind of interesting that that wire comes over here, connects to here, comes out there, and then goes down this board. Like instead of having the cable just come here and then a wire, you know, another cable going up there, they just did the other way for some reason. And then there's a fuse, and then there's an MOV, a X capacitor, a combo choke, which is interesting since there's not Y caps. And then there's a bridge rectifier with bulk capacitor. Comes over here to a switching power supply, it looks like to me. Looks like the switching FET, the transformer, which I'm guessing is a flyback, and then rectifier diode here for the output. We have two bulk capacitors going to this output connector right there, okay? So that's pretty interesting. Here's an optocoupler feeding the output back to the input, so to regulate the output, okay? So that's that board. Okay, let's flip this over so we can look at this one. All right, so like I said, the power comes into here and leaves to that board from here. But on this one, we have this transistor, it looks like, and a poly cap, and it looks like another MOV capacitor, and in this case, it's an NTC, a thermistor, okay, inrush current protection kind of thing, to this little small bulk capacitor. I don't see a switching power supply here, so that's really curious to me. This chip right here is the TM1640. That is the display driver for the display on the other side. This guy, okay? So it's on the other side of this board, and it looks like a 5-volt regulator here, and down here it looks like an op amp and another transistor, and these might be optical couplers, I'm not sure. My guess would be that one is feeding back for the soldering iron, the other one's for the hot air, and then they go up to these chips up here. So yeah, just an interesting construction. I would have expected to see a switching power supply here or something, but yeah, it's pretty simple. That's why it's so lightweight. Hey guys, by the way, I'd love it if you subscribe, give the video a thumbs up. If you like the video, if you don't like this and you like the video, still give it a thumbs up. Don't vote on this, okay? Because whenever I review things, people don't like what I review. They give it a thumbs down. But if you like the video, thumbs up. If you don't like the video, thumbs down. You're not voting on this. You're voting on the video, okay? Just want to clarify that because I reviewed something that a lot of people didn't like and they just gave a lot of thumbs down, even though I think the video was pretty good. But anyways, let's jump back to the video. By the way, if you're a YouTube member, paying YouTube member or Patreon, and you're interested in this, send me an email, okay? And call it Toolour, Toolour. So I'll know what you're talking about, all right? And if you're anybody else interested, let me know as well, okay? All right, let's jump back in the video. All right, guys, what do you think? 2 big thumbs up to Toolour for sending this out to me. I kept the sponge dry. I like to watch them go, but anyway, I'm probably going to find a home for this thing. My wife just sold a really nice Southwire multimeter for me. That was awesome. Guys, I figured out what this little wand thing was. There was a little plastic bag with this little springy thing. I didn't put it on quite straight, but that's for going underneath the IC, and then you can put a little spring tension, so when you're heating up the chip and the solder melts, that this thing will just pluck it off. You don't want to put too much tension, it'll fly up in your face. As a matter of fact, that's why it's a good idea to have safety glasses when you're soldering, so you don't get splattered in your face. But yeah, soldering tips, 2 of these tweezers, which are, they look like really nice tweezers to me. The air pump, a little spool of solder, 6337, extra tips. You get the hot air and the iron, and it's ESD. For some of you guys really like that. You know, within the same brand, some irons will be ESD. They'll say ESD. Those guys are tied to 1 meg resistor, so that'll, you know, if you have ESD, it's high voltage, low energy, right? So high voltage across the resistor will leak off that current and protect you from ESD. So the 6337, by the way, guys, that has a melting point that's ideal, and it stays in the molten stage. The eutectic point they call the melting point. It's when you put the 2 metals together, it's interesting how they react to each other and how the temperature drops the melting point, and it'll go from a molten, you know, liquid molten state to a solid state in a very quick time of 6337 when you remove the heat. 6040, not quite as optimal. So 6337's the one I always buy, but they both work great. But yeah, why not get 6337? Is there a reason? You guys let me know. You guys got to laugh at my soldering skills. It's been a while. I've been rusty. I did put together a board, and I have another one of these boards. I got some more boards I'm going to put together. You can see them right there. They're looking at me. So yeah, when I'm down here soldering in front of my face, I do a better job. And you know, rework is always a pain, right? Especially when you have to heat up a big board. So much easier to solder those FETs on than to unsolder them, right? And when you're soldering and they got the big pads, you can just keep on putting solder in, and it just makes this big old thing on the other side, you know, that just big old puddles, you know, big old ball of solder. And yeah, so then when you're trying to rework it and suck all that up through the hole, you can tell that took me some work. So, all right, guys, thanks for watching. Appreciate it. Let me know what you think of this. I think that's an awesome starter station. You got a lot of stuff to work with and a really good price. Right now, I think until October, it's down under $60, like 55 bucks or something like that. So that's just crazy. But all right, guys, we'll see you next time. Thanks for watching.